Good morning, everyone. We have our next speaker, Nimantha Baranasuriya. He is a co-founder and CEO at Ackcio. Will speak on improving productivity and safety of oil and gas industry via long-range wireless mesh technology. I'm giving this mic to Nimantha to take this conversation ahead. Please.
Thank you for the introduction. Hi, everyone. As I was introduced, my name is Nimantha. I'm the co-founder and CEO of Ackcio. And at Ackcio, we build wireless data acquisition systems for industrial monitoring applications. So it's a pleasure to be here today to talk about how the experience that we've gathered over the past decades of years spending time on these wireless networks could be shared with you all for improving the state of the art in the oil and gas industry in terms of monitoring. All right, I hope my presentation is shared.
Yes, it is visible.
Okay, great. Thank you so much. All right, cool. So let's get started with the topic. So today I'm going to talk about how the productivity and the safety of the oil and gas industry, oil and gas projects can be improved by using long-range wireless mesh communication technology. So it's a pretty new technology actually in the field. Lots of people are familiar with LoRa kind of star-based technologies, but long-range wireless mesh networks are picking up and they are currently being used a lot in other industries. So I thought of taking this opportunity to educate and to share our experiences in deploying these long-range mesh, new long-range mesh technologies in industrial spaces, and how I'd love to share how it can benefit the oil and gas industry as well. So let's get started with the presentation. So I'll just give you a quick introduction to the company and myself before I get started, so that you have an idea from like where this information is coming from. So as I mentioned earlier, we at Ackcio, we build data acquisition systems for industrial monitoring applications. We are headquartered in Singapore. One of the founders, so we started the company in 2016. And right now we are serving clients in over 25 countries in construction, mining, rail, and infrastructure industries. And we have an office in Canada as well, based out of Calgary, that is assisting our, and our team members over there are assisting our clients and projects in the North and South American markets. So about me, I'm the co-founder and CEO of Ackcio. I did a PhD in wireless networks in Singapore, at the National University of Singapore. So after I graduated, I wanted to do something meaningful with all that experience that I had gathered in spending a lot of my own life on wireless networks, and that's how Ackcio was born. I'm very passionate about taking these technologies, like new wireless technologies, and putting them into good use in industrial spaces, like in changing the norm, or assisting all these different industries do better monitoring with new wireless technologies. So that's why I'm here today as well, to share some of my experience with you, and hopefully it will help some of you, or if not all of you, make better use of newer wireless technologies in your projects in the oil and gas industry. So let's get started at the talk. So I'm dividing the content into three main sections. So first of all, let's do a very quick look. Let's take stock on what's happening in the oil and gas industry and how things are being monitored. And next, I'll give a very quick overview on different long-range wireless technologies, or LPWAN technologies, that the industry can use to implement monitoring solutions. And thirdly, let's talk about how why long-range wireless networks are better suited for monitoring in industrial settings, like in oil and gas projects. And finally, how these long-range solutions can help the oil and gas industry to do better monitoring. So let's get started with the first part and take a very quick look at what's happening right now in the industry. So most industries, including oil and gas, do a lot of monitoring to achieve a number of business goals. So I'm outlining 6 here. These are quite obvious, actually. So monitoring is done to reduce costs, to ensure that the assets' lifetimes are extended as much as possible. And there's a lot of regulations that govern industrial projects, including oil and gas. So these monitoring practices are required to ensure that all these regulations are met. And of course, we don't want to expose any of our workers to unnecessary risks. So that's another key requirement. And with monitoring, we get data that is required to manage risks. So if something disastrous is going to happen, we get warned, based on that information, we can take quick remedial actions to make sure these things don't end up in a disaster, right? So that's a key risk management element. And finally, with monitoring solutions, we can get data to increase the productivity of our projects as well. So these are quite straightforward. So to achieve these business goals, of course, we need to deploy monitoring solutions. So there are 3 key monitoring techniques that are currently being used. This is, again, not very specific to oil and gas. This happens in other industries like construction and mining, where we are involved as well. So the first key solution is, of course, PLC and SCADA-based systems, where everything is wired. So if it's like a very small refinery kind of a setting, everything can be wired up. Like all the sensors that need to be monitored can be wired to a PLC, and with using a SCADA system, they can be controlled. However, this becomes quite expensive to deploy, right? Because if there, say, for example, the refinery spans across a huge geographical area, you'll be running lots of different cables, and then it doesn't get, it's not extensible easily. So if the refinery grows, you'd have to end up installing more systems, installing more wires, and therefore the maintenance becomes quite a big headache as well. Satellite monitoring is also used a lot, but it's quite expensive. It's not straightforward. And also there might be obstructed areas in the oil and gas environments that satellite monitoring could not cover. And finally, with manual monitoring, this is also expensive because you need to send an army of workers or technicians to do manual inspections. And that ironically exposes them to risks and decreases the safety, right? You're conducting monitoring to improve safety, but by exposing more workers to the site, you're decreasing the safety as well. And also manual monitoring can't be done frequently. So let's say you're like using manual monitoring to inspect things every week. So between 2 visits, a lot of things can change, especially if the project is quite dynamic. So these are not the best of ways that monitoring can be done. There are better ways, especially using wireless technologies, that can actually help assist the industry to do better monitoring. So the problem, the high-level problem with these monitoring solutions is that the price and the complexity and the time are quite high. So all these are very expensive solutions. The complexity of deploying them can be quite high, as we talked about earlier. Like in PLC systems, you'd be laying a lot of wires, and maintaining that can be quite complex. And with workers, for example, the time consumption for monitoring is very high. And as I said, like between 2 visits, a lot of things can change, and you might not know what's happening between 2 different inspection visits. So this is where wireless, the new wireless technologies can come into play. Like all these IoT technologies have been improving a lot. So there's a lot of movement in the industrial space, like in all these different industries, in terms of moving towards adopting wireless solutions for conducting better monitoring. So let me just give you a very quick idea of how this works. So as before, in any project, you first need to capture these physical parameters and convert it into digital values. That's where sensors come in. So in the oil and gas environment, you can think of like things like temperature sensors or gas sensors or water level sensors or flow rate sensors, right? So there are so many sensors that already exist, and these sensors now need to be scattered around to monitor different parameters in the refinery. So let's look at a refinery, for example, right? So these sensors now need to be monitored. Now, again, back in the day, you would either connect them to a PLC or send workers to inspect them or take manual readings or deploy like a satellite system. But without doing that, in a wireless setting, what would happen is these sensors would be connected to a transmitter, a radio transmitter called a node. Typically, most systems refer to this device as a node. So the sensor would be physically connected to the node, and these nodes typically run on batteries, and therefore they can be placed anywhere in the project. So all the different sensors therefore would be connected similarly to nodes. And finally, there would be a central device called a gateway or a hub. So this is where all the data should end up at. This is the master receiver. So these nodes periodically will take sensor readings from the sensor that they're connected with and use wireless radios to transmit their data to the gateway. So this is what changes when compared to PLC systems and manual monitoring and so on and so forth is that this process is entirely automated, and it's quite easy to expand as well. So if the refinery grows, you can install more sensors and more nodes as and when you need it. It's pretty ad hoc, so it's quite easy and scalable. And finally, when the gateway receives all this sensor data, it can upload it to either an on-premise software system or a server, or if it has cloud connectivity, it can upload it to a central software system that the refinery maintains, so that all stakeholders have access to all this data for real-time decision making. Right? So this is why wireless is better. It's less expensive. It's highly scalable because you can deploy systems very easily without worrying about wiring and all of that. And it increases safety because you're not exposing workers to unnecessary risks. So the price, complexity, time triangle that we talked about earlier become really low when switching over to wireless IoT or wireless-based monitoring systems. So this is why we argue that industrial projects are better served by wireless systems because it's easy to deploy, easy to extend, and it reduces a lot of maintenance headaches as well. So now when it comes to deciding how and which wireless technology to use, this is where things get a bit complicated because there are so many different technologies out there. So in the second part of the talk, I just wanted to compare some of these different technologies to show their pros and cons and argue as to why long-range wireless mesh systems are better suited for oil and gas. So let's go through that comparison now. So if you look at all these wireless technologies that are out there in the market, they can be divided into two categories, star and mesh. So let's see what they are, right? So as again we discussed earlier, there would be sensors that need to be monitored. These sensors would be connected to nodes, right? And there will be a central gateway that should receive all this sensor data wirelessly. Now in mesh, and the gateway finally would upload all the sensor data it receives to a central server or a software system. So in the mesh setting, it is exactly the same. There are sensors and nodes, the gateway receives the data and uploads to a server. So far everything is the same. Now this is where things change. So in star systems, every node has to transmit its data directly to the gateway. Whereas in mesh systems, that's not the case. They talk to the gateway as well as to their peers, right? So the importance is this. Let's say there's an obstruction in a project, like a massive tank or something that is blocking a radio link. So in star systems over here, when the obstruction is there, this link would get disrupted because there's an obstruction in the way, and all the sensor data from this particular node would not be received by the gateway. All that data is lost. So when it comes to doing risk management and doing very stringent monitoring practices, such lapses would cause problems for you. But in mesh systems, if there's an obstruction and the link gets disrupted, because they talk with other devices as well, like this node would continue to send the data to this particular node and through that to the gateway. So in that case, the data still is received by the gateway when there are obstructions in place. So this is why mesh systems are typically better in industrial settings, because there are so many obstructions, so much of interference, and they perform really well in such settings when compared to star networks. So in terms of different radio technologies, so the most common star technology that is used in industrial settings is LoRa. When it comes to mesh, traditional mesh networks used to be built on Zigbee kind of radios. So in industrial settings, it's not really usable. But what's better now, like a new technology that is out there, is called Wi-SUN. So when it comes to radio brands, LoRa uses the ISM spectrum, which is like 868, 920 megahertz, and gives a very long transmission range. Zigbee uses 2.4 gigahertz, so it's like Wi-Fi at home or Bluetooth, which is very short in range. And Wi-SUN is actually a combination of like the best of both worlds. It gives a long range link and gives a mesh as well. So it also operates like LoRa in the ISM spectrum, but gives quite a long communication range as well, like up to about 10 kilometers, which is comparable to LoRa systems. So in terms of pros and cons, so star networks are really simple in terms of the architecture, and they consume less power as well. And the disadvantages are it's only usable for small projects, because again, I'll illustrate this later on. If there are a lot of obstructions and if the project is very complex, their reliability would be lower when there's interference as well. And in underground settings, like if there's multiple layers of underground deployments, then again, LoRa becomes impractical, because if you recall, all the transmitters have to talk to a central gateway, which is not doable in every setting. Mesh networks offer so much more benefits. So they're massively scalable because you can deploy them anywhere, and the devices, because they talk to each other, form very reliable connectivity and data collection in almost any setting. So it's suitable for both large and small and underground projects as well. And the other very cool thing about mesh systems is that they give you bidirectional communication. So not just you can have the nodes talking to the gateway and the gateway talking back to the nodes as well at any point in time. The cons of this, it's a bit more complex in terms of the architecture when compared to star networks, but when designed properly, the industry or the users, they don't even have to worry about that, because the mesh is constructed automatically. And also the power consumption is relatively higher when compared to star networks, but however, still it's pretty on the like, although the power consumption is higher, the batteries still last like several years even while running a mesh. So let's again look at some examples in what happens in star systems. As I talked about earlier, every device has to talk to the gateway directly, but there might be some nodes, right, deployed so far away from the gateway that might not be able to reach, or there might be obstructions, and therefore in LoRa kind of star systems, the reliability can be lower. But in mesh systems, what happens is they still have long-range links, so they continue to talk with the gateway directly, and the others who can't reach the gateway are not left behind. So they talk to their neighbors, and the neighbors forward the data to the gateway. So when you have long-range mesh system, the reliability can be so much higher. So I also want to take a bit of time to debunk a few myths that are surrounding mesh systems, because people have been burnt by deploying short-range or the Zigbee-based mesh systems in industrial environments. So there's a lot of negativity on mesh networks. So I just want to share some thoughts on that. Like the first key disadvantage that people talk about mesh networks is a critical path. So let's say there is like this path that is being used by this node to send the data to the gateway, and a critical path is like if one node gets lost, then people argue that this node does not have a path to reach the gateway. That is not correct, because in long-range mesh systems, typically because the communication distance is so long, each node has multiple links or multiple options to choose from. So there's no notion of a critical path in almost every single project that we've dealt with, because again, they have multiple paths to choose from. So when one gets disrupted, they automatically switch over to a different path. And also there's this argument that they are not secure, which is not correct, because most new age long-range wireless mesh systems use AES 128 like very secure encryption algorithms to make the projects quite secure, or the transmissions very secure. So there's no question about security here. And the third point is that they're more expensive, because in short-range mesh systems, people have to deploy lots of repeaters. But again, because we are talking about long-range mesh systems, you don't need repeaters, because the nodes themselves act as repeaters. So in most cases, you don't need to install additional repeaters since they already have like few kilometers of a transmission distance in each hop. So a few kilometers into several hops would give you massive coverage in almost any project. So there's no additional cost involved. And in contrast, actually, in star systems, the cost can be higher, because again, if you recall what we talked about earlier, in star systems, every device has to talk to a central gateway. So you might end up deploying multiple gateways to provide coverage for different parts of the project. And because gateways are more expensive, they're the most expensive component in wireless monitoring systems. In star systems, therefore, the cost can dramatically shoot up when it gets like very deep, when the deployment setting is quite complicated, because you need multiple star systems to cover the entire project. So these are some of the myths that I wanted to like debunk, as I said earlier. And in the next 3 slides, I wanted to talk about why, like some of the really cool features and pros of long-range mesh systems as well. So one is reliability. Again, if you recall earlier, I talked about how they automatically move away from obstructions, right? Because every device has multiple paths to choose from. So if one gets obstructed, it automatically chooses a different path. The other aspect of that is interference. So let's say you have a project where using this green frequency, like say channel 1 with on 868 megahertz to form the network. And one fine day, maybe there's a cell tower or something that starts blasting on the same frequency, or you have another wireless deployment that runs on the same frequency, right? And that would cause an enormous amount of interference in the network, and that would cause the reliability to go down. So now in these long-range mesh systems, what happens is they automatically detect that and switch over to a different frequency. Like earlier they were on a green frequency, and now they switch over to a blue frequency automatically. So there's no user intervention necessary. The devices automatically take care of this frequency hopping. It's called synchronized channel hopping. So when that happens, the interference happens in the green channel, but the nodes and the gateway are on the blue channel, and therefore the reliability is quite high. So in most long-range mesh systems that run on channel hopping, the reliability can be as high as 99%, even in these very challenging industrial settings. The other is on-demand downlink. So the devices not only talk between themselves and send the data to the gateway, but the gateway can send data back to the nodes as well. So this becomes important, like for example, when the gateway wants to push updates or configuration updates to the nodes, it can be done at any point in time. So this becomes very advantageous, again, for industrial monitoring projects. The last really cool thing about these mesh networks is time synchronization. So these networks automatically are tightly time synchronized. That means all of these devices, although they run independently, they have almost the exact same time running on their clocks. So they are synchronized up in the order of milliseconds. So when all of them take sensor readings from the sensors that they are connected to, all those sensor readings are taken almost at the exact same time. So this becomes very important, especially if you're trying to correlate sensor data. So you want all that sensor data to be taken in throughout the entire project at the exact same time, which can be definitely achieved through these mesh systems. So these are three key unique advantages, again, that a lot of people are not aware of, that I just wanted to share during this presentation. So that brings us to part 3, how long-range wireless mesh systems can be used by the oil and gas industry for implementing better monitoring practices. So I'm using 3 very simple examples here to talk about pipeline monitoring, monitoring refineries, or even monitoring offshore rigs. So in most of these projects, the use case is very simple. There can be lots of different sensors to be monitored, like pressure, flow rate, tank levels, leak detectors, and things like that. So all of those sensors can be connected to these long-range wireless mesh communication nodes and then monitored in real time. So again, to illustrate that, I'm using the same example as before. So let's say in the refinery, you have those sensors deployed everywhere, like flow rate, temperature, leak, tank level sensors. And all those sensors would be connected to the nodes, as we discussed before. And they would have, again, this deployment would have a gateway. And these devices would use the long-range radios and form a long-range wireless mesh network to collect all that data and send to the gateway. And in doing so, you reap all the benefits. If you recall, you have very reliable links. They mitigate any interference issues. They mitigate obstructions. And they're very secure as well. And they run on years for on batteries. So it can be easily extended. Like if the refinery grows and you want another temperature sensor or a pressure sensor in a different part of the refinery, it can be just added in. And that node would automatically join the network and form a very reliable communication system. And then finally, once that gateway collects all that data, it would be uploaded to either an on-premise server or software system for monitoring, or even to a cloud server. Right? So this is exactly how a long-range wireless mesh communication system can be deployed in oil and gas settings for to implement very, very reliable monitoring solutions. So that brings me to that's the bulk of the story that again I wanted to share, like how all these long-range solutions can be deployed in oil and gas. So I just wanted to give you a very quick introduction to Axio and show how these technologies have been used by us in other industries like construction and mining to again solve the same problems that the oil and gas industry is facing as well. So at Axio, we built this a very reliable data acquisition system called Ackcio Beam that can be used in industrial settings to monitor various industrial sensors. So the solution has three components. The devices is essentially our nodes and gateways that connect with existing sensors, and our patented long-range mesh communication protocol that binds all these devices together. And finally, the software that you would use to set up and monitor the deployment in your projects. So it works as exactly like what we talked earlier. So the sensors are connected with nodes. They run on batteries, and they can be deployed anywhere in your projects. And then they use a long-range mesh system to talk between themselves. So the radios have a transmission distance of up to 10 kilometers in ideal environments, but in realistic settings, it can be a few kilometers. And finally, once the gateway receives all that data, it aggregates everything and uploads it using either an internet connection or even a private network to a destination of your choice. So this is the cool part of the solution that we provide. We don't link the system with cloud service. So a lot of industries are very particular about the security or the privacy of the data. So once you deploy the system, it's entirely closed. It's a closed loop system. So all the data would be channeled to your servers and software, and we would not know even like how many devices or where is the system deployed. The system is entirely secure and private in that sense. So it is currently used in multiple industries like construction, mining, rail, for monitoring various geotechnical and structural sensors. Again, as I said, we don't provide sensors. The sensors, instead, the devices are compatible with existing industrial sensors. So you can get sensors from any manufacturer and just plug them in, and the devices take care of the monitoring aspect. So it has been deployed in various projects, construction and mining projects all over the world, in tunnels and mines and like underground construction projects as well. And we have deployments in very severe weather conditions, like the first two was our pictures taken in Norway, where the deployments happened in the middle of Christmas. And the one on the right is actually in a very hot environment in Peru, in a mine over there. So the devices have been designed to withstand such harsh weather conditions and environments like as would be expected in oil and gas environments as well. So there's a quick map of where the clients are located. As I mentioned, we have clients in almost every continent, and we have two offices, one in Calgary, a sales office, and our headquarters are based in Singapore. So yeah, coming to the last part. So the system, we talked about it earlier, it runs on a long-range mesh system, and we support many sensors directly, pure plug-and-play operations. And it's suited for underground environments. It has been designed, as we showed in the pictures, for very harsh environments, IP67 rated. Therefore, they can be easily deployed in outdoor environments. And we have certifications for the radio, which allows you to deploy them in almost any country in the world. They're battery powered. Batteries last for several years in almost any deployment condition. Quite cost effective to deploy and easy to set up and maintain as well. And in terms of business benefits that you can gain as oil and gas project owners, first of all is that you would be able to reduce your monitoring costs by up to 70%. So this is the highest saving that we have seen in some of our monitoring projects in the construction and mining industries when clients have implemented it. And finally, and it also helps you to implement state-of-the-art risk management process, because all this data is communicated with like almost 99% reliability to you. So with all the data, you can implement very, very strict risk management practices to keep your projects and workers safe. Finally, it increases the productivity and reduces the non-productive time, because you always know what's happening in the projects, and that helps you to streamline your processes really well. And with that data, when dealing with your assets, you can do predictive maintenance and also enhance their lifetime, because you know when things are about to fail, so you can take remedial actions very fast. And as we discussed, this increases the safety of everyone, all the stakeholders in the projects, and also helps you to comply with regulations that govern all industrial projects as well. So that's pretty much it in terms of the talk. So just to summarize everything and put things into perspective. So we first looked at the oil and gas industry and argued why like monitoring happens in terms of like what are the benefits of doing monitoring, and how the current monitoring solutions can be improved by using wireless IoT-based systems. Then we looked at different wireless technologies like star versus mesh, and argued why long-range wireless mesh-based systems have superior performance and better results in oil and gas environments, and in like any harsh environment for that matter. And finally, showed a little bit about what we do at Ackcio and the kind of systems that we build to help automate these industrial monitoring practices in industrial settings. So that's it from me. Thank you so much for your time today. I hope you found the talk useful and you learned something. And if you have any questions, you can reach me on email. I'm available on LinkedIn as well. So I'd be happy to answer any queries that you might have and help you get along with your monitoring projects in the oil and gas industry. Thank you so much.